to set the stage, I think it's important to think about the scale of the problem that's kind of presenting us. Much like oil and gas, mineral processing is a depleted industry. So what that means is that even if demand is staying steady, the world still needs to identify and bring new mines and refineries into production to make up for the fact that we're depleting the current resource base. Now you stack on that, massive demand growth across AI infrastructure, electric vehicles, grid expansion, aerospace, defense, robotics, you name it. You kind of have this perfect storm of a supply crunch coming online, and we anticipate needing, over 500 new mines and refineries to be built over the next 10 years. And compounding on that problem is actually that, these mines are getting harder, more expensive, and more complex to develop. So, we've gone and for the most part mined most of the, let's say, good resources that we found to date. And so what that means is that, overall, if we take copper as an example, overall grades that we're finding in these ores are decreasing pretty significantly. We used to be mining 1% copper, and now we're, new mines are getting developed at, half or 0.6% copper. So that means to make the same amount of copper, you're having to move almost twice as much ore. The mineralogy is getting more complex, which makes the refineries more complex. And then the mining side is also getting more difficult as well. So new discoveries are getting deeper, which means, more advanced technology to get to the ore. It means longer times to develop, longer times to cash flow. It means temperature becomes more challenging in the underground. It means water infiltration becomes more challenging in the underground. So all of this is making it, it's getting harder to find these new assets, it's getting more expensive to develop them, and we need a lot more of them. And so hopefully that sets a little bit of stage, kind of like the technical challenges that we're facing. On top of that, the Western mineral companies have kind of continued to, I'd say, like cede market position to China in general. And within that lens, if you can look at this as a glass half empty and say, a large chunk of the U.S. mining workforce is going to retire in the next 10 years, we're slower and more expensive in developing projects as they are in China. But I think if you look at this as a glass half full, it's essentially showing that there is a roadmap to execute on this, and it is possible, right? Most of these major Chinese mining companies have all been started in the last 10, 15, 20 years, which really isn't that long in the grand scheme of kind of the market that we're playing in. So it's showing that new entrants to the market can show up and really develop and scale their businesses. And really, not surprisingly, the way you need to do that is to execute quickly and execute cheaply. So there are some structural disadvantages that the U.S. is facing in terms of labor availability, cost, and schedule. And we here at Mariana Minerals really think that the answer to all three of those problems is being autonomy first and software first in the way that we develop, execute projects, and ultimately operate them. And we think that's like true vertical integration. There's a lot of companies out there selling spot solutions, but we think that the value really comes into like building an overall integrated platform across project development, across mine operations, and across refinery operations. So what does that mean in particular for Mariana Minerals? Really, we see ourselves as a project developer and owner and operator of the mine and mineral refining assets. There's actually been a lot of venture capital dollars that have funneled into the exploration game, using big data analytics, using machine learning, using reinforcement learning to try and hone in on where we should be looking for ore and metals. And that's really exciting to see. And I'm very excited to see kind of what gets developed out of that. But really, one out of maybe every 1,000, exploration projects will ever actually turn into a mine. And so there's actually more of a bottleneck in the actual project development lifecycle. So, after a discovery gets made by a junior mining company, their stock price will tend to climb. Maybe there's some excitement, and really, they're trying to get acquired because those teams are small. They're really out there trying to, de-risk the geology of an asset. They're not there to build a project. And so, eventually, if they're not acquired, the market tends to realize that, the likelihood of this project ever getting developed is quite low. And so their market cap tends to drop pretty drastically. And these projects enter like what's called like the orphan period, where there's some amount of geologic de-risking that's been done, but there's no one actually out there who the market really believes is going to be able to develop and bring this mine into production. And that's where we see ourselves as Mariana Minerals coming in with a new value proposition to really accelerate the development and deployment of these projects to get those metals into production. And how do we do that? Really, we see three main verticals that we're working on, building both our team and our software platform to address. And I'll spend a little bit of time talking about each of these in a bit more detail. But, Capital Project OS is really about trying to, more closely match the Chinese EPC execution model of doing, process development, process engineering, detail engineering, and construction in as accelerated and compressed as a time frame as possible. Kind of eschewing a bit of the traditional stage gate EPC project execution. And to do that, obviously introduces some risks. And so how can you use, agentic engineering and advancements in LLMs to really create an integrated data system to make that possible? MineOS is really about deploying autonomy and getting to as near real-time mine planning as possible. Then PlantOS is really about trying to leverage advancements in reinforcement learning and machine learning to build optimized models of the refinery, and then eventually get real-time control systems to optimize for what we call like reward functions, which could be profit, yield, throughput, etc. Today spent a little bit of time talking about each of those. Capital project OS, to execute a large, billion-dollar, multi-billion-dollar capital project, requires, quite literally an army of people, right? You have hundreds of engineers and designers working on different parts of the plant. You have thousands of construction technical professionals. You have to do thousands of engineering tasks. You have to release thousands of purchase orders. You have to manage, inflow and receipt of, steel, pipe, cable, equipment, you name it. And today this is all, really a highly manual process. Big ETC companies have built their business models around trying to manage these data flows. But we see a ton of opportunity in building an integrated software system that's going to allow us to automate as much as possible so that, instead of needing a dozen project controls professionals and a dozen project engineers to manage data information flows, really you have a software platform and an ecosystem that allows you to see the live status of project execution at any given point. And, when you look at evaluating potential changes, really see and automate the impact of the cost and schedule impacts of making those changes, all kind of in a unified software platform. On the mine side, there's hundreds of activities going on every day in the mine, from drilling and blasting, from mucking, from hauling, from moving material to the refinery. And really here, there are spot solutions in terms of automation. And where we as Mariana see a lot of the value is really on sitting on top of those and kind of what we call the orchestration layer, where how can you actually create an integrated planning platform that's constantly updating your geologic model and your mine plan, where every time you drill and you blast, you're learning something new about the ore that you didn't know before. How can you capture all of that data and get to real-time mine planning so that you're constantly making the best decision with the information you have available in front of you? And then the last one we have is what we call like PlantOS, where, today when you're building a new mining or refining project, typically you'll build a steady state heat material balance. You'll do your best to optimize that heat material balance. But really mining's a highly dynamic and highly variable process. So, your ore grade is constantly changing, your impurity profile is constantly changing, and that's from project to project. But even within a single mining pit, you're actually changing every time you go through the mining process. And so really you need your refinery, if you want to truly optimize your yield and reduce your OpEx, you really have to be responding dynamically to what it is that you're actually mining at a given time. So we spend a lot of time building first principles based and then also empirical based machine learning, reinforcement learning models to build simulations of what we expect the plant to do based on the ore that's coming in and the different operating conditions you run the refinery at. And once you build a highly accurate model of how the refinery is going to operate, you can start to put dollars and cent signs to all the inputs and levers to essentially create models that will predict your OpEx, and then you can then go in and optimize in real time to maximize yield, throughput, and refining. So that's what we call PlantOS. And really we see those three as like critical to unlocking cost, schedule, and performance of our mines to be able to go compete with China and really go scale the rest of the Western mineral production. We're growing really rapidly right now. So I think our team is we're 200 people. Predominantly based in the US and really have an active mine in Southeast Utah, where we're deploying a lot of the autonomous technology that I just talked about, as well as a lithium refinery out in East Texas, where that's really kind of the first demonstration of PlantOS. So a ton of really exciting work going on across the board.